Assalamu alaikum, I'm back with applicationsecurity.io. Today we are going to do the security misconfiguration part 2. In the part 1 we have seen that there is a two-factor authentication compromise done by Bob. So in part 2 this exercise we will examine a misconfigured security fix that the developer of CoinPay implemented to prevent click checking, allowing attacker Bob to maliciously bypass the security checks. So let's see what is the fix that has been performed by the Alice. So this was the chat in which Alice told Jake to do some fix, but Jake said, "Not sure if that's a good idea. Some of our internal apps and third-party partners require coinpay.com to work with iframes." So he told him about the content security policy or X-frame options to whitelist these customers. So Jake said, "I need to read up on content security policy header. I'm familiar with X-frame option, but not sure if we can whitelist multiple domains. Let me think." Then he said, "Actually, I think I have a solution. How urgent is this?" He said, "Till next month." So once he implemented the solution, again Alice contacted with Bob to again pen test this iframe issue, and Bob received this email. So before the Bob start pen testing, let's analyze what the Jake did with the code. So let's analyze this code. The developer has implemented the pre-handle request interceptor, which conditionally sets the value of X-frame option, X-frame header. So if someone from his domain opens this iframe in his website and tries to embed the website of CoinPay, there is a pre-handle which checks for X-frame option and set it automatically. For example, first it extracts the origin header from the request to see from where the request has been initiated. In the next step, then it checks whether the origin value match one of the two predefined regular expressions. As Jack said, there are multiple third-party applications that interact with CoinPay. So these are the two regular expressions that Jack has created to only whitelist these two domains. These two domains are in the end.coinpay.com or whatever the domain which has with end.coinexchange.com are allowed to embed CoinPay as an iframe option. Apart from this, all of the things are denied over here. So if the origin value match with this regular expression or this regular expression. So come over here. If it does, the allow from value of the X-frame option header is set to the current request origin, allowing the website to be rendered. So if the website origin is .coinpay.com or .coinexchange.com, then X-frame option is set to the initiating domain. Otherwise, if anyone other than this asks for the iframe embedding, he will be returned with the deny option. Okay. So let's move next. Otherwise, the X-frame option is set to deny and the other websites won't be able to embed this CoinPay into their iframe. So let's test this fix. So Bob has created a simple iframe to test if the iframe embedding is possible. There is a simple iframe over here with the URL of CoinPay. Let's move next. Let's copy this, and now Bob will host his own domain. And now let's move next to check if the crypto-news.com iframe is able to launch the CoinPay. So CoinPay refused to connect because the origin is coinnews.com. So this does not allow the iframe to reflect the content of CoinPay in his website. So reviewing the browser output, we can see that Bob test index.html was unable to load coinpay.com via the iframe, thereby protecting CoinPay's website against click checking or UI redirecting. Okay. To further understand why the browser was unable to successfully prevent this CoinPay from being rendered inside the iframe, let's intercept and analyze the HTTP request and response generated by Bob's browser using an application web proxy. The application web proxy could be burp or owasp. So let's refresh this page again and see what was the request and what is the response that was received. So let's analyze the response, as the get request was for coinpay.com. Okay, and this was the host value and what we received in the back. Analyzing the HTTP response from CoinPay, we can see that X-frame option header is being set, which indicate whether or not a web browser should be allowed to render the page inside an iframe. So we received the option with deny. So it means we are not able to render this iframe on our website. Since CoinPay developer have configured the X-frame options to deny a configuration parameters that prevent the website or web page from loading within an iframe, the browser raises the error refuse to connect thus. So let's move forward. So Bob is a security researcher and he know how the commonly people use regexes to fix their whitelist issue for multiple domain. So he had tried with one more option. He had registered this xyzcoinpay.com domain. He assumed that developer had set a fix in which whatever the domain is ending with the coinpay.com would be allowed to render the iframe value as coinpay.com. So what he tried, he again run the web server on that domain. Let's paste it over here on xyzcoinpay.com. He started the web server. Now let's see if he is able to, when he'll open xyzcoinpay.com, as the developer supposed, it would not render the iframe, but it has in the end coinpay.com. So this website would be able to render the iframe, and again the click checking attack is again possible. So let's move further to analyze what happened actually. So you can see that these were the two regexes, regular expression in short, that was actually matching the content of domain through which the request was initiated. Developer used this dot. Developer was considering that this any subdomain of coinpay, for example api.coinpay.com or blog.coinpay.com, is allowed to embed the iframe, but xyzcoinpay.com was not allowed. But he missed that this dot has a special meaning in regular expression, and in the same this dot is a special meaning in a regular expression, and developer did not escape it this thing. So the original regex that was left is anything that has in the end coinpay.com would be allowed to render the iframe. So he registered xyzcoinpay.com, and this regex allowed him and added him into the whitelist. Since xframe option header does not allow multiple URL whitelisting, the developer decided to programmatically check the origin of the request and set the header accordingly. So to achieve this, he implemented the pre-handle request interceptor, as we have already seen. So from the request, he extracted the origin header value and matched it with the with the regular expressions. If it matched with the regular expression, the header value is set to that specific origin, it is allowed, otherwise it is set to deny, as we have already seen this. So however, notice that there is a mistake in the regular expression. The developer intended to use the dot symbol as part of URL. This symbol was assumed to be the part of the URL for any subdomain of coinpay.com, and he forgot to escape it. Hence the dot is considered as special regular expression character, which means match any symbol. Okay, so let's move forward. So xyzcoinpay.com is an allowed domain on this whitelist, so the click jacking attack was possible for that case. So to prevent this kind of security breach, developers should be extremely careful when using regular expression for security configuration purposes, as it is quite easy to overlook a mistake in such an expression. In our example, regular expressions could be completely avoided by using the content security policy header instead of the xframe option. The allow from directive of which is actually considered deprecated and does not work in modern browsers. So instead of xframe option, go for the content security policy and set it like static is for any subdomain of coinpay is allowed to embed the iframe option. In the same way, any subdomain of coin exchange is allowed to embed the iframe of coinpay.com. So this was a simple thing that could be done to avoid the security misconfiguration. So this is all from security misconfiguration part 2. Jazakumullahu khair. We'll see you in the next video.